We are going to be talking about the design of parking structure today. We're going to be focusing on the system aspects of parking garage design, the gravity and the lateral force resisting system. So the objectives today are to provide an understanding of the structural design of precast prestressed concrete parking structures, including gravity load framing. We'll discuss vertical elements of the lateral force resisting system, and we're going to be talking about diaphragm considerations. We will provide an understanding of the use of shear walls in system design for precast prestressed concrete parking structures, including their configurations, some simplified stiffness analysis for load distribution, and considerations of resistance to overturning. We're going to provide an understanding of the use of shear walls in the design of structures with a consideration of wall diaphragm balance, the alternative approximate period calculations, and wall structural modeling considerations. We will provide an understanding of design issues and solutions for moment resisting frames and diaphragms. Consider ordinary moment frame issues, special moment resisting frame issues, and diaphragms in precast parking structures. So the load standard that we work with is ASCE 7, minimum design loads for buildings and other structures. It gives us a gravity load, a uniform gravity loading of 40 pounds per square foot live load and a 3,000 pound concentrated load. This is a change that was made over 20 years ago from the 50 pounds per square foot live load and 2,000 pound per square foot concentrated load after a survey study of 8 parking garages was conducted and studies were made of the dynamics in parking garages. There is some concern or consideration going forward that the vehicles that were studied in 1999 may not be the same as what is coming forward now, and yet the load was reduced. That study considered that the uniform parking load based on the survey could have been 35 pounds per square foot. Certainly with the advent of electric vehicles, we're concerned that the vehicles may weigh another 1,000 pounds greater for the weight of the batteries that are going into them. But considering that the vehicle range that limits the design of parking structures to ordinary parking structure loads is 10,000 pound gross vehicular weight rating, and the consideration of the conservatism that was originally undertaken, that's not an immediate concern. There is research that is going to be sponsored by the Prestressed Concrete Institute that is to study the effects of axle loads, that is 2 wheels and fatigue, based on increased load conditions in order to determine if there is a need to increase the criteria. But right now, this is the criteria that we work with. Now, for the lateral system, we're generally dealing with wind loads or earthquake loads, low, moderate, and high seismic, depending on seismic design categories. We also may have some soil and hydrostatic loading conditions that can occur with precast concrete. It's possible to build walls with precast concrete and have them backfilled, but it has to be done with a great deal of care and attention to the amount of force that has to be transmitted through the precast system diaphragm and ultimately to the vertical elements of the system to bring it to the foundation. Parking garage configurations have specific challenges. Ramps is a prominent one because we have to look at the structure and determine what is the contribution of the weight to a level if we're considering seismic. What is the effect because the ramps break a framing plan into sub-diaphragms and how they're considered, and they also develop potentially unintended load paths. Stair and elevators are usually at remote locations, and they create remote stiffness that has to be regarded in the way that the building is connected and the links between expansion joints. And then also we're subject, because of the desire to have large open bays, large open space, that we may end up with long diaphragms, particularly for architects who would prefer not to have any walls inside of a building at all, when that could obstruct views for parking.